I'm going to show you how to work out the area between two curves. So I'm just going to draw up a grid, a sort of Cartesian plane here. I'm going to just make up some functions. So this could be f of x, and this could be g of x. Okay, and what I'm going to do is I'm going to just pick some terminals a and b. So let's just give some terminals here, a and b. And what we want to do is find the area between the two curves. So let's just imagine we had just f of x on its own. I'm going to try and use colours here. I've got yellow. If I was to work out the area between the curve and the x-axis and the terminals a and b, I would get this whole area here, which hopefully you can see in yellow. Now let's look at g of x. If I was to work out the area between the curve g of x, the x-axis and the terminals, I would get this whole area here. And so because I want only this area up here, which I could just represent with some green dots, I don't know if you can see the colour, or I could just shade the whole thing in here, right? If I want just this area here between the two curves, if I take the entire area of f of x and I subtract the entire area of g of x, or the area that's created between g of x and the x-axis, I'm left with this desired shaded area, which is between the two curves. So pretty much if I was to set up an integral, I would say the area of f of x with respect to x between a and b, take away the area between a and b g of x with respect to x, would give me my desired area. Now this can be simplified to go, well actually let's simplify it. If we work out the area between the terminals, the curve, or the parts a and b, the terminals a and b, of the curve f of x take away g of x with respect to x, I get exactly the same response. I like to simplify it and say, look, if you've got a sketch, if we work out a new expression here and integrate between these terminals, we can say top curve take bottom curve. And that expression can be integrated to give us the desired area. It does not matter if the curves then are sitting above the x-axis, they cross the x-axis, or they're sitting below the x-axis. This new expression that you create by top minus bottom will sort out any negatives and will make it so that you end up getting a positive area, and you get the desired area between the curves top minus bottom. The important thing about this though is you need to have a sketch. You need to see what area you want, which curve or line is sitting at the top and which curve is sitting at the bottom. So I'm going to do an example now where I want to find the area bound by the curve y equals x squared minus 2 and the line y equals x. And I need a sketch. And without the sketch we can't tell which is on the top and which is on the bottom. So firstly I need to find out where they intersect. So when I'm looking at how they intersect, I need to solve. So let's find what the x values are. So I'm going to subtract the x over and make it equal to 0 and factorise. Luckily it factorises nicely, so I've got my x minus 2, x plus 1, and I use the null factor law, which tells me that x equals 2 or x equals minus 1. So there are my two intersections between these lines. I am going to do a quick sketch. You should always find where any x and y intercepts are when you're sketching a graph. I do have a video on how to sketch graphs. So x squared minus 2, something like that, where we know enough about the function to know where it cuts the y-axis, and then the line y equals x, as you should know enough about that, cuts through the origin at 0, and we now know the 2 points of intersection because we've just found those. This one here will be minus 1, and this point here will be at 2 when x is 2. Now we want the area bound between these curves, or this line and the curve, so I'm looking for this area here. So what I now can see with the sketch is that the line y equals x, put that one, should label it, sits on the top, and the curve y equals x squared minus 2 sits underneath. So I need to create a new expression to now integrate to get the desired area that I've shaded. So we do top minus bottom. I'm going between the terminals minus 1 and 2, and my top is x, and I want to take away the bottom, which is x squared minus 2. Now be careful when you're subtracting, sorry, that should be x squared minus 2. Be careful when you're subtracting, because you have to make sure you subtract the whole thing. And of course, that's going to give me x minus x squared plus 2. So I'll just go to rewrite that underneath. Minus 1 to 2 of x minus x squared plus 2 with respect to x. Now I can go on and integrate this. This new expression will give me the desired area. So let's integrate. We get x squared over 2 minus x cubed over 3 plus 2x. And I'm integrating between minus 1 and 2. Now I'm going to substitute the values in and find out what that area is. So 2 squared is 4, over 2 is 2, minus 2 cubed is 8 over 3. So I've got 2 minus 8 over 3, plus 2 times 2, which is 4, so plus the 4, subtract, and sub in negative 1 here. Negative 1 squared is 1/2 over 2, obviously, minus, and that becomes negative 1 cubed is negative 1, making it positive 1/3, minus 2. Okay, now I'm getting to the bottom of my board now, so I've got to work everything out. If I was to work all of that out, hopefully, if I've done it right, I should get, now why have I written a 2 there? I've sub 2 in there too. Oh yes, that's correct. Hopefully when I work this out, I get the correct answer of 4.5. So I'm just going to clear some space. And it equals 4.5 square units, which is beautiful. And pretty much that will work as long as you create your new expression, top curve minus bottom curve. You get a new expression to work the area out between two curves.